All right, in this video, I'm going to cover while loops. And while loops are programming control structures that allow you to execute code over and over again while a condition is true. In this case, I'm making a little hailstorm, right? If I look up and I see all these little hail balls coming down, each one is one iteration of my while loop. I just keep creating these little pieces of hail, dropping them to the ground. So if you want to make spawners, you really should learn about while loops. Let's go ahead and get a fresh world and start working on our while loop. All right, here's a fresh world. There I am at the Home tab. I'm going to add a script, but not to the workspace. I'm going to go to Server Script Service. And that's a great place to put scripts that aren't directly associated with a model or part in your game. So I'm going to use that Server Script Service, hit the plus sign, add a script, and then I'm going to rename that to Hail Spawner, right? You can call it whatever you want as long as it makes sense. Now I'm going to add a variable up top, local counter equals 1. My counter is going to be my loop counter to see how many times I go through my loop, right? Now I'm going to add my loop while true do. Oops, there we go. And this is just like in the if statement. This condition has to be true in order to execute the code. What's different is that it'll just keep looping through, keep executing the code until this turns false. In this case, it's not going to turn false because true is always true, right? But we'll go ahead and I'll show you how to do that in a minute. Let's put a wait statement in, induce a little bit of a wait, 1 second, and then I'm going to do a print out. I'm going to say counter equals counter. So the first iteration through the loop, an iteration is one time through. When everything executes once, that's one iteration. We'll go ahead then here, increment our counter by 1. So it's going to take the old value of counter, it's going to add 1 to it, and then reassign it to counter. That's the new value, right? That looks kind of crazy, especially if you took algebra, you're like, oh, I got to balance the equation. Nah, this is assignment. So whatever happens on this side is assigned to that side. So this is going to increase my counter 1, 2, 3, 4 like that, right? And now there's a shorthand way of doing this that you really should learn because it's in like every programming language. You can do this. You could do plus equals 1. That's the same thing. So it's going to take the old value of what's here and add 1 to it. So this will go 1, 2, 3, 4. And continue upwards. Let's go ahead and try it. Oh, look at that. We need our output window to see. View, output, there's our counter. It's counting away, 7, 8, 9, etc. Cool beans. All right, so let's make this so the condition can be false, right? Let's show you how the conditions work. I'm going to get rid of the true, and I'm going to say while counter is less than or equal to 7. Right? And then to show you that the loop will break, down here I'll say, whoops, print finished with an exclamation mark because it's exciting. So let's go ahead and do that. Run it. 1, 2, 3, 4, 5, 6, 7. Finished. So what happened was this counter hit 8 and said, oh man, it is not less than or equal to 7. Let's break. And then we got down here, we're finished, the script stopped, right? That's kind of cool. All right, so let's go ahead and make a part and plop it in the world. That's even cooler than a counter. Counters are kind of boring. Let's see, we can do it right under the wait. We'll do the wait, say local, part equals Instance.new, and then this is a speech quotes part. So we are creating a part with code. Just like we added a part with our little part button when we were on our base plate, we're creating it with code here. We are creating a new instance of part, right? And then we're assigning it to this variable so we can change it, right? And we can do things with it. First thing we need to do is this part's not going to show up until we give it a parent that's in the workspace. So we're going to have to say part.parent equals, And we can actually give it the workspace. It could be a child of the workspace or it could be the workspace. Cool beans. All right, what else should we do? We should reposition it. Its default position is going to be right in the middle of the world. That's at 0, 0, 0. But that's going to be like halfway inside the base plate, right? The base plate's right at the 0 mark. So let's just go ahead, take a look at position. If I go POS, position is expecting a data type of vector 3. All right, so we can't just give it a value. We have to give it a vector 3. And then we're going to have to do this new, right? Sometimes you have to do new, sometimes you don't. You'll get good at when to use it, when not to use it. I'm going to make it 0 on the X. I'm going to make it 20 studs high, 0 on the Z. So the X and the Z is the position on the base plate, and then this is the height, right? The Y is the height. All right, what else should we do? Maybe we can change the size. Size equals, that's also a vector 3. We need 3 values, right? Vector 3 dot new, and then we need 3 values for our, what do you call it? Length, width, and height. Let's just make it 1 by 1 by 1. All right, let's go ahead and run this, right? Let's go ahead and run this, play, see what's happening. Look at that, little parts falling down. See that? You see these little inlets though? And then on the top, you have the little stud. That's from the Lego days. That's the default part when you create a default part. Oh, we only did 7. That's right, we have the loop stopping at 7. Let's take a look at that. Let's go to our workspace. Here's a part. If we go down to surface type, right, or surface, right, look at that. Bottom surface is inlet, top surface is studs. But we're going to make smooth balls, right? And we're still going to get those little inlets and studs on a circle. We need to change that. Let's get rid of this right here. We need to get our parts top surface, right? And that's of type Enum.SurfaceType. Remember that? Enum.SurfaceType.Smooth, right? We need it to be smooth. Part.BottomSurface equals Enum.SurfaceType.Smooth, right? That's going to make the smooth ball. Well, while we're here, let's go ahead and make it white, right? So we have BrickColor. BrickColor, that's accepting type BrickColor. Well, we know how to do that. So we'll say BrickColor, and we'll do white, right? Oh, but we need this. Why didn't that show up? That's weird. White. Oh, there we go. I don't know why it didn't show up. So here we're actually calling a function. Here we're just calling values, right? That's why we have this. I don't know why they did that. They should have just done it the same way, just return a property, but that's how they did it. Anyway, you're going to see a lot of kind of strange inconsistencies. You'll just get good at using it. Cool. So we got white. Oh, let's make it a ball too, right? While we're here, we'll say shape, right? Shape. There it is. And that's Enum.PartType. That's what we got to give it. So we'll say Enum.PartType.Ball. Cool. Let's see what we got. There we go. Look at that. Stacking like that. Let's knock it over. Bow. Nice. All right. We only get 7 of them. We got to make that. We got to make more than that. And we got to do it faster, right? So let's get rid of this. We're going to make it run forever, right? So let's get rid of that. We're not going to put true in here. I'm going to show you a trick. What you can do, if you put a wait statement in here, what happens is wait actually returns the amount of time that it waited. And in these conditionals, even in the if statements too, if you have a number, it's going to be looked at as true, right? So if you have a number, it's true. If you have true, it's true. But if you have false or nil, and we haven't gone over nil yet, but we will, those two are false. So very few things in Roblox is actually false. This, if you're a C programmer, this is going to mess you up because in C, a 0 is false, but not in Roblox. Only the, or Lua, only the nil or the false is false, right? But this will work, right? This is cool. That way we save a line of code. I'm going to get rid of this 1. And now what is that time? The default time is 0.03 seconds. And that's as fast as the wait as you can have. It's actually more like this, 0.0299999, like this, something like that. But that's practically 0.3. You can't make it go faster than that. All right, so that's going to go fast. What else are we going to do? We can get rid of our counter. Should we do that? Oh, let's take a look at this. Look at this. I use local part here, right? What does that mean? Is it the same as local here? No, it's slightly different. Local for counter means I can see the counter everywhere in the script. Local inside this while loop means I can only use that part inside the while loop itself. If I take my counter, I go down here to this print statement and I paste it, it will be fine. There's no red. It's going to print the number out when it finishes. In this case, it won't finish, right? But if I put my part, ooh, red, unknown global part. Well, that's because I said local, and it looks at the block and says, oh, it's local to this block, right? So the scope of this variable is this block. So you get a little bit better at scope, right? I know it's still kind of confusing, but that's all right. If you do it like me, it's going to work. All right, what else should we do? Should we play it? No, let's do something else. We haven't really done anything. Let's go ahead and change the position, randomize the position. Let's go local. I'm going to do this variable called RND. It's going to be a random number generator, Random.new, and it's actually pseudo-random because computers are deterministic. You're never going to get true randomness in a computer. But we're going to generate pseudo-random numbers random enough, right? So we got this random number generator here, the variable for it. We're going to go above position. I'm going to do another one of these local variables, and I'm going to say x rand. Look at this, colon. Why not a dot? I don't know. That's just the way they did it. So colon, next int, and I am going to say -50 to 50, and that's going to be the range, including the -50 and 50, of which this next integer is going to be when we go through the loop, right? We're going to get our next integer, next random number, and it's going to be that x between -50 and 50, right? The reason we have these colons, I will get into instead of a dot. So dot is for properties and functions. Colons are for methods. I haven't gone over functions or methods. So don't worry, just know for now, use the colon. All right, so that -50 to 50 on the x is actually going to be, this is our x, right? This is the 0, plus or minus 50 on both sides. Cool, we're going to localize our storm. All right, let's copy this. Control C, we're going to do one for Y, we're going to do one for Z. Y, Z. Now Y is a little different, right? Because that's height, it can't be negative, or it's underneath the base plate. Let's make that 150 to 250. That's the height in the sky. Cool. Now for our position, instead of these numbers, let's just put an X, Y, and Z. X, Y, where's my Y? There we go. And Z, right? Those are random numbers generated right here. Cool beans. And we could do it for size too, right? We could say, now size I only need one because it's a circle. So X, Y, and Z is going to be the same size. Let's go local. I'll just call it size with a lowercase. Random, I'm not going to do next integer. I'm going to do next number because I need decimals, right? So numbers are, can be decimals. Integers are like 1, 2, 3, 4, -1, -2, -3, right? So we'll do 0.0121, and then we'll just put the size in for the X, Y, and Z. Cool. We're running really fast, running forever. Look at that. And they're different sizes. They're little tiny ones. See how bouncy they are? Let's change that. Do you know why they're that bouncy? Because this is a default type of material of plastic, and so is the base plate. So Roblox game engine tries to predict how plastic on plastic would be, and they decided it was bouncy, which is probably correct. Also, if you let this keep running, you are going to crash your game eventually because we're not getting rid of any of these parts. So we got to fix both of those things. Let's go ahead and hit this pause button. Let's do the bounciness first. So this base plate, boom, base plate is made of plastic. Where's my material? There it is, plastic. Let's change that to grass, right? And now I don't want that decal. It's kind of fuzzy looking. Let's open up base plate, select decal, delete. And I think I'll make this green too, because I already called it grass, right? So base plate, I'm going to go to color, instead of BrickColor. I'm going to hit this green, and I think I'll make it a little darker. So just move this down a little bit. There we go. Cool. All right, so that's grass. That should be less bouncy than plastic. Let's go to our script, hail spawner, and then we'll change our material. Part, what is it, material? A material needs Enum.Material.Type, right? Enum.Material.Type, and Ice will work, right? Ice you can use on a base part, and we extend base part for our regular part, or terrain. So we could use it, right? That's what's important. We can use it. Cool. And we need to get rid of those little hail balls so that they don't clog up our world. We got to give them a time to live, right? So I'm going to say local debris service. So I'm just going to call this debris. Game GetService. So this is a service that we can get, that we can use in our game. We're going to say debris. All right, debris service is going to mark things to be cleaned up after a period of time. We're going to need that with a spawner. So go down here after you create your part. We'll go ahead and say debris, and we're going to use that goofy colon again instead of a dot. Add item. We're going to add our part, and then we're going to give it a time to live. I'm going to say 10 seconds. So it's going to, each part will live for 10 seconds. All right. Another thing we can do is we could get rid of this counter stuff if we want. Should we do that? Let's do that. We don't need the counter because we're not really using it. It demonstrated its purpose. Cool. All right, we are done. I'm going to move this line up here, make this code look a little tighter. Yeah. All right, let's run it. We got our spawner. Good, and it's not so bouncy. Let's look at this ball here. It's going to disappear. Boom. So they last for about 10 seconds. That's pretty good. We're not going to clog up our world. All right, I will see you in the next video, and we'll start doing some for loops, a different type of loop.